Good morning, everyone. My name is Jaime Badui, and I'm making this presentation for my Telecommunication Networking class with Dr. Kaleem. The topic I chose for this video is the OSI model. Now, due to the nature of the topic, this video is solely for educational purposes. Okay, so before we start off with the OSI model, let's go on to do a brief history on what it is and how it came to be. Before the internet, there was ARPANET, which is the world's first operational packet switching network to use TCP/IP. The reason I bring that up is because the OSI is segmented into two major parts: the abstract part, which consists of the seven-layer model, and the set of protocols, which include TCP/IP. The seven layers are what I'm going to be focusing on with this presentation, and the 7 layers are traditionally divided into two segments: the upper layers and the lower layers. The lower layers fall under the network architecture, which focuses on how the electrical signals are sent from one device to another, and the upper layers fall under the networking protocol suite and focuses on the application aspect. The main reason that this was designed this way is so that you can interchange the architecture of the connectivity without having to change the protocol suites. Okay, so I'm going to try to break down the OSI model. And basically, I'm going to separate all the 7 layers and break it down and explain piece by piece. So starting off, we have the application layer. Now, the application layer is a very abstract layer where the human and the machine interacts. This is basically when you're looking at your desktop and you open up an application. That interaction between you and the machine, that is the abstract layer that I'm talking about. That's the application layer. So whenever the user actually sends a command that opens up, let's say, Internet Explorer, and you're checking your email, the interface you're using to check that email is application layer. It could be Internet Explorer, Firefox, Chrome, Outlook, any application you think of. This is basically the, if there's any problems with the application itself, like let's say Skype decides to crash and the program is not responding, there's a problem within the application layer. Now, moving on, we have the presentation layer. Now, this is the layer that the operating system is on, and any acts that you do in the application layer is transferred over to the presentation layer. Now, any problem that may arise in the presentation layer could be let's say there's a device driver that is messed up, or the operating system has a setting where your security protocol does not allow something for you to use on the internet. Your firewall is set too high, and you're not able to go into a certain website. That is a problem in the presentation layer. Now, there's a more significant problem if there's a virus that goes into your computer, into your operating system, and deletes a library, and the OS can start to affect other applications within your computer. That can cause major damage to your system. Now, after the application layer, it goes down to the session layer. Now, the session layer is pretty much an interaction between one computer and the other. Now, in order for computers to interact, then you create the session. Now, session layers problems can be if there's a miscommunication between one session to the other, or if you're administering a website and you have settings configured incorrectly that cause problems with this layer, like let's say the PHP configuration file, and the sessions don't want to connect properly. This is a problem in the session layer. Now, let's say you're trying to get into your bank information, and you go to bankofamerica.com, and you're trying to look for pretty much your credit card information and see your past purchases, and you're creating a session between your computer and the servers inside Bank of America. Now, that session that you're creating has to go through the OSI model. Obviously, it has to go through the internet, has to go to IP, has to go through the session layer, has to connect to the servers in the Bank of America. Now, if there's some configuration within your system or the Bank of America server that does not allow you to connect, then the session is going to close and you're not going to be able to see the information that you want to see. And that's why sometimes you might get frustrated whenever you're trying to check your bank information and you can't. Now, after the session layer, we have the transport layer. The transport layer, this is the window, like, there's a certain way of the information is being transferred from one device to the other. There's a thing called windowing, which is a process of data transfer, and everything that has to do with data transfer is in the transport layer. Now, this is very important because the computer has to decide how big of information it can go through and how much of it can go through at a time. And when you transfer information, you're transferring packets of bits through the network onto another computer, and when that data is received, the other computer sends an acknowledgement to say to the other computer that yes, I received this information. If no acknowledgement is received, then the other computer tries again to send it. But also this is where TCP and UDP come into play, because TCP, Transfer Control Protocol, those are guaranteed that it's going to be sent. When you send a TCP packet, the other device is going to send an acknowledgement saying, I received it, don't send it again. But if no acknowledgement is sent and the session is timed out, then the original computer is going to send the information again. Whereas a UDP packet, when the information is sent once right away, and if there's a acknowledgement signal, that's great. If not, then it's not going to send it again unless the user decides to send it again. Now, the next layer that I'm going to talk to you about is the network layer. And the network layer, this is pretty much where where the IP addresses are set. This is also where the router goes, and this is where the router operates and where the IP addresses operate. And if you were to go to a URL, if you type in IP address, you type in URL, and that is incorrect, and you don't go to the right website, and you end up going to a different website that you did not want to. For example, you type in a website that you put in the name of a website. Turns out it was supposed to be plural, but you don't put the S at the end, .com, and sends it to another completely different website. That's because you're sending the link. You go into another website to a different IP address, and that, if you have that kind of problem, that problem lies in the network layer. So if your router dies or just stops working, and it stops connecting to the internet, stops connecting to your computer, then that is an issue in the network layer. The next layer that I'm going to talk about is the data link layer. Now, the data link layer is a layer where the switches operate on. All the computers get plugged into a switch so that they can talk to each other. And also, this is where MAC addresses reside, the media access control addresses. Each individual device has a certain MAC address assigned to it. Now, in order for computers to interact with each other, they have to go through the network and go into these switches. Because if you have like a system of computers in a network that cannot really talk to each other instantly, because one computer might be talking to another computer, and so the switches will decide which information goes in first, which information doesn't go through. Let's say if we have one computer, say we got computer here, computer 2 here, computer 3 here, we got computer 4 here. Now, these computers go into a central hub that are all connected, and computer 1 wants to communicate with computer 2, but computer 3 wants to communicate with computer 4, and And computer 1 is trying to send information to the switches so that it can go send the information to computer 2. But computer 3 is trying to send information to the switches as well and send to the computer 4. Now, there's a collision in data that if computer 1 sends the information at the same time as computer 3 and the data ends up getting colliding, then it's going to slow down the system. It's going to send the information back, and when the computer receives the information back, it's going to wait a random amount of time, let's say 0.5 seconds, before it resends the information. But in this case, there's only 4 computers, so the switches will probably operate easily and send the information at a certain time. Sends to 2, 3 is going to send the information to the switches, and the switch is going to operate to send the information to 4. And the interaction between computers are very smoothly with such a low amount of computers. If you were to add more computers to the system, then we have a higher combination of data being transferred to these switches. So now the switches need to operate at a faster rate, where let's say 1 wants to talk to 2, 4 wants to talk to 6, but 3 wants to talk to 6 as well. And so the switches need to understand, the switches need to be able to take the data coming from each individual computer and send it to the next computer without having to collide with the data. Because if there's a collision of the data, it's going to be sent back to the computer. The computer is going to wait a certain amount of time, a couple of microseconds, and resend the data. And this could be when you're in like an office building and there's a lot of computers working on the same server in the same network. There's going to be a lot of collisions. It's going to be slowing down the process. So that's why switches are very important. And if there's any problem that arises within the switches, then that's a problem that is residing within the data link layer. Now, if you're trying to look for a problem and you know that there's a problem with the data link layer, this is where you go. It goes to the switches. Now, the final layer that I'm going to talk to you about is the physical layer. The physical layer is pretty much exactly what it means, the physical aspect of everything that goes on within the network. Let's say the computer is connected to another computer. It's going to have to use wires and cables and all that stuff to connect to each individual component. All the cables and cords that connect to the computer to the network. Let's say you have a Cat5e connecting to a router, and the router is connected to the modem using another Cat5e, and the modem is connected to the wall outlet, and that's how you get a physical connection. Now, if a cable is cut or it's not connected properly, then that is considered a layer 1 problem. And if you have a layer 1 problem, you have to go straight to the source, fix the connection, take out the wires, reconnect it, fix the wires, do what you gotta do. And I was told that most of the networking problems that we receive is going to be because of the physical layer. Most of the time the connection is made incorrectly, or there's a wire that's broken, and most of the time the problems within the network is going to arise from the physical layer. Alright, so let's review on what we talked about in the OSI model. We talked about the application layer, which is more of an abstract layer where the human and the machine interacts. This is where the user actually uses the applications and sends a command, for example, using Internet Explorer, Firefox, Chrome, or Outlook, or Skype. Now, the presentation layer, we talked about how it's basically in the operating system, and any action you do on the application layer is transferred over to the presentation layer. And any problems that may occur in the presentation layer could include the application that like in the operating system, any library that may have been deleted, and the applications might not run properly. Or, for example, disk drives might not be connected properly, and the operating system might not acknowledge it. The session layer is basically the layer where the sessions are created between two computers. And in order for the two computers to communicate with each other, they need to create a session. And just like it says, like I said earlier, when you go into a bank website, and you leave it idle for too long, the session would time out and it will be disconnected. The transport layer, it's basically the transfer of data between computer to computer inside the network. How are the data going to be transferred through? What kind of packets? How big are the packets? What is the rate of the packet being sent? Also talked about the TCP and the UDP packets, how the TCP are guaranteed to be sent, but the UDP are not always doesn't always get an acknowledgement that it was sent, or that it was received. So wrapping that up, TCP, you send a TCP packet, it receives an acknowledgement saying it was received. If no acknowledgement was received, it sends it again. UDP packets, you send it once and that's it. It doesn't send again. In the network layer, this is where the IP addresses reside, and this is basically where the router operates on, and your IP addresses operate on this level as well. And when you're trying to connect to another IP address, trying to get information from a server from another IP address, and this is the layer where the communication between the routers, your router, and the server for whatever whatever website you're trying to contact. If you get a IP address incorrect, or you get the URL incorrect, then it's going to send you to a different website, and that's most of the problems that happen in the network layer. Now in the data link layer, this is where the MAC address and the switches are. Now each individual device has a specific MAC address assigned to them, and the switches are in the network there to facilitate the transfer of information. Now, as I said earlier, whenever there's one computer trying to communicate with another computer, the switches are operating accordingly so that they can be able to send information smoothly and without having to bounce it back to the original computer. If that happens, it usually happens because there's too many computers and not enough switches, and the server or the network starts to crash. And finally, the physical layer. Physical layer is pretty much where all the physical stuff is connected in all the computers. And the reason the majority of the problems occur in the physical layer is because mostly because too many wires, there's no organization, and people tend to break the wires, or the wires ended up being connected incorrectly. And whenever there's a physical layer problem, you're gonna have to go into the wires or into the network and physically fix the problem. Now, I talked about how the OSI model, what the OSI model is, and why is it important. So let's recap on that. The OSI model is basically a model that every technician will go through, and having a good understanding of the OSI model and the layers will give you an understanding of where you need to start, and where you need to start looking for the problem. How do you break down why the reason is that there's a problem within the network, and you can use this model to really understand how the network is working so you can fix it. This is a very useful tool in order to start troubleshooting, and if you can actually understand this model correctly, you don't need a in-depth understanding of the OSI layer, but it's good to have a basic understanding of each individual layer so you can know how to solve any problem in any layer: physical layer, data link layer, network layer, etc. So, with that being said, this concludes my OSI model presentation. Thank you.